Hello everybody and welcome to the Kube Vanguard. I've been absent for quite a while. I've been doing quite a few talks and videos and traveling, and so I just didn't have time. However, I want to restart these, and I thought this would be the perfect time to restart the Kube Vanguard videos after V100. And what I wanted to start with was to go through my V100 session, underground session. So this year at V100, they had a V100 underground evening, so to speak, for the V100, so the MVPs, the Vanguards and Legends, where there was food and drink and everyone could talk and also see some sessions. And I did one session myself. All these sessions were, by the way, rejects, CFPs that didn't get accepted, and that's the main reason they did it. So that was a lot of fun. And so we did that, and I'm going to present that today in two parts. First, just the slides, and then a second part will be the actual demo. But V100 was fantastic. It's always interesting. I did some sightseeing too. I went to Sunset Cliffs, which is incredible, right up Pacific Ocean, these cliffs. Went to the Old Town, and then Little Italy with some of my fellow V100, and they're all Object First Aces. And I wanted to show that right off the bat before I started my my presentation, just to show you the brain power and the result-oriented, driven vision types that we are. This is This is during our walk. So we originally went out to walk to go look at the aircraft carrier, which is like a museum. But then Nico Stein kept dragging us further and further. We ended up a lot further. And then we turned sideways and we ended up in Little Italy, and we actually sat down and had a drink. But then we all decided that we were pretty exhausted because on top of all the walking at the conference, we also walked there. So it really accumulated. And we decided, okay, we better find this train. It's like a big streetcar thing, but long, like a subway over ground. There's a word from LRC, which can take us right back to the hotel. Okay, but the problem is the stops are located kind of strategically. You have to find them. So this is where we did our battle plan, so to speak. You have here Scott Patterson, Veeam Legend, also Object First Ace. We have Nico Stein, who's a Veeam Vanguard. And look at this. He's the one I think who's leading the cause here. You have Luis, who's questioning this, going, I wonder if he's right or not. Joss is hiding behind Luis there. So Luis, a Veeam Legend and Object First Ace. Nico Stein, Veeam Vanguard and Object First Ace, and then Joss is a Veeam Vanguard and Object First Ace, and Joss has his finger too. So I'm photographing, so nothing to do with this. In the end, we ended up walking. So we kind of, I don't know what happened. We thought the stop was there because you couldn't see, right? It was down a bit. Anyways, I think the real goal, Nico wanted to get us back into shape, and so he, pretended to be trying to sort it out, but instead we ended up walking all the way. Inside joke. Okay, let's go to my presentation. But just to show you some of the fun that you have, and when you're walking around talking loudly in a foreign city, or we're not so much foreign for some, but not your usual city. Okay, so let me just find my presentation. So, Kasten application-aware backups. Now, when I was thinking about doing this, I thought, Kasten, not everyone knows it, not everyone uses it. I don't want people to fall asleep or leave, and so I thought, I gotta spice this up. It's gonna be Kasten, but I wanna show some of the things that Kubernetes can do and things that Kasten can do. So I spiced this up. What did I do? What spices everything up nowadays? Gets investors crazy, people terrified of losing their jobs, becoming baristas like myself. Yes, you guessed it, AI. So my talk was Kasten application-aware backups, keeping our AI vector database properly backed up. So I'm basically using an AI application which is relying on a database which is being hosted in Kubernetes and backed up by Kasten. Yes, okay. So my first part of the talk will be this. I'll do my slides, and then the second part will be the actual demonstration. Okay, so what's the agenda for my talk? Well, first I'm going to talk about my hybrid AI architecture. And don't worry, I will explain these terms in detail in the next slides. So this AI architecture is a Python RAG application backed by MongoDB. It's actually two Python applications, but I'm kind of making it all one because it's a two-part kind of step that you have to use. Okay, then I'm going to talk about why I'm using MongoDB, and then I'm going to go into application-aware Kasten blueprints. All right, so starting with the hybrid AI architecture. What does RAG stand for, and what does it mean? So it stands for officially Retrieval Augmented Generation, RAG. It's actually very simple when you think about it. If you think of an LLM, which is a large language model, it's huge. It's got a huge amount of information in its little brain, And so if you're going to ask it general questions, it could be quite good. It might lie, it might hallucinate, as they say. But you're definitely going to have a problem if you ask it, for instance, about some internal documentation in your company. It will not have a clue. And what's worse, it might not say, oh, I don't know your internal documentation. It might lie and make something up. And so if you're gullible, you might think it's telling the truth. So that is a problem. Then there's another problem. Let's say this LLM was created in November 2024, and we're in April 2025. Well, it's not going to know of anything that took place after November 2024. So let's take a really scary example. Let's say there was a new pandemic that started in February 2025, and we're all locked down again, and we can't do anything, and there's no toilet paper. Okay. And you ask the LLM about that. It's not going to have a clue. Okay. It's going to think we're still in sunny, happy 2024 November. So that's another problem. So one of the ways you can deal with this, and when we're talking about dealing with this, what are we talking about? We're talking about the when we ask an LLM to generate an answer. That's what we're doing. It's generating answers. Or we're asking it to create something like a file or a presentation or something. It's generating these responses. Okay. So retrieval augmented. What does that mean? It means it's going to retrieve from somewhere information and then augment the response. That's simple. So what do we do basically? It's very simple. We take, let's say, our internal documentation. We embed this using another model, a model which is specifically or more well designed for this than others, to embed this into a token, into a vector database as tokens. So it basically converts the words into numbers and stores them in a vector database. Okay, the vector database is special for this purpose. And then the RAG application, when you ask it a question, you're going to tell it to rely on the context, and the context is that Mongo database. In my situation, it could be something else like Pinecone, another one, or any vector database. Basically, you're telling it in the instructions, go to there to get the answer, please. Don't think about whatever you've got, flying around your head. And so this really increases the accuracy of the answers. If you, for instance, are dealing with specific documentations, again, domain-specific knowledge they've got here in the slide, and up-to-date information, you'll get enhanced responses, accurate, up-to-date, contextual, domain-specific information about your applications. So that's what RAG is, okay? Now, there are other things coming around nowadays as well. There's agents, I was going to say Veeam agents, but AI agents, which can go and scrape the internet very well. So one LLM can say, hey, I don't know this. Can you check the website of this company, get the information? So that's also a possibility, but RAG is still very, very important and works very well. All right, so here is my RAG application architecture where I built myself. I've been studying AI for a bit and playing with it. I am nowhere near an expert, don't get me wrong, but I've got enough knowledge to be dangerous, okay? So won't let me near the lab. Well, they did actually, but I didn't do anything bad. So what do I have? I have an Ubuntu VM with Ollama. Ollama is a program which allows you to run AI or large language models locally. Okay, so you don't have to go to a cloud, ChatGPT or Claude. I use Claude myself, which is good in cases where you don't want the information to go out into the internet. Now these companies claim that it's secure, but again, you're gonna have to trust them, and maybe there are things you just want to do locally for many reasons. Maybe your internet goes down. Okay, so it's a VM with Ollama. I do not have a GPU, and this is a very big constraint. If you have a GPU, things are gonna run a lot faster. So in my case, there's definitely a speed problem. This is my home lab, and I'll show you in the demo. It works a little bit slower than in my company lab, because in the company lab, I've got a more powerful VM, and also I was able to tweak, but I'll show you that. Maybe I'll show you both to compare them. So what do I have? I have two applications, okay? They're Python applications, which Claude built for me. I'm not really a Python coder. I know a little bit, but nothing really serious. So these were totally built by Claude, a back and forth interaction. So I'm telling Claude what I want it to do, and it's doing it, and then we're having to fix it for the particular situation for this Mongo database, because obviously this Mongo database is in Kubernetes. I'm on the same VM. I also have K3s running, a small Kubernetes distribution. So all that had to be taken into consideration. So there was a lot of back and forth, but eventually got done. The first program I have is indexer.py, and all this does is it indexes the document, so tokenizes them, and puts them in the MongoDB vector database. Okay, so that's where they sit. So I've got a folder, and the program runs. Anything it sees in that folder, it's going to tokenize. and it sits in there afterwards. Then I have a program called API Pi, and this is just a chat box with an LLM, and it's just asking, I'm asking questions, and it's querying the MongoDB vector database to get the answers. And I also created another very similar program, except that it's just relying on it in its LLM. The reason being is I'm gonna ask the same question to that and to the other one, and you'll see the difference. The one that does not talk to the MongoDB vector database will not be able to answer correctly. Okay, why MongoDB? Well, MongoDB actually is quite a good vector database. I mean, there's some smaller and leaner and meaner ones, but if you're talking production, it's pretty good. It has this thing called the built-in KNN algorithms for native vector search. So KNN are K nearest neighbor, and as I understand it in my brand new kind of persona of trying to become an AI expert, you have the vector database, and let's say you have cat and dog and mouse, and they'll all be in a similar vicinity. And so if you ask the LLM or ask whatever the searching the vector database, what does a cat eat? It'll hover over to that area, and then other considerations come in, and it'll tell you mouse. That's very simplified version of what's happening, apparently, according to Jeff. All right, it's high performance, they're low latency searches, multiple models, various embedding types are allowed, unified solution MongoDB, so the vectors and the metadata are held together, which is good apparently. Reduced complexity, yes and no. I put this in Kubernetes, so it's reduced complexity from MongoDB standpoint, but a little bit enhanced complexity when it comes to the standpoint of Kubernetes. Horizontal scaling, so sharding capabilities. I've also been looking at Elasticsearch recently a lot, and sharding is something fantastic. So it's, as I understand it, it's like having little replicas. So in Elasticsearch, you have documents, and you'll have different shards, and you can even load balance. So if you've got a lot of queries for something, it can get from the other shard, and there's basically a little bit of HA there too. So if you have multiple nodes, obviously. If you don't have multiple nodes, and you don't know if you can't really have shards. So I've got a single node MongoDB node database inside of a single node Kubernetes cluster. So, all right. So it's perfect for applications and low latency vector searches, but also Kasten has a ready to go blueprint, which I only had to change a little bit to find the right secret, and it worked perfectly. So that saves you a lot of work. Okay. Application-aware backups or native Kubernetes native backups. So I have to repeat this every time I talk about Kasten because I still see it. People using VM backups to back up Kubernetes clusters. So if you have multiple node Kubernetes cluster and you've got nothing in it and you do a VM backup, okay, it might be okay. The minute you start loading it with a lot of things, you could get into big trouble because the VM backup, like Veeam, is not aware of what's happening inside Kubernetes and inside the Kube API. And so you really want to use Kubernetes native backup tools. So it's just like anything, AWS or Azure, you want to use the Veeam appliance for Azure, the Veeam appliance for AWS. You don't want to use, I mean, you can use an agent, a Veeam agent inside each VM, but for efficiency, for better backups and speed and integrity, use native backups. So Kasten is what we're using. Okay, so no VM, no agents. It also has export of CSI. CSI is container storage integration. It was specially built so that vendors can write plugins for their storage to Kubernetes without having to, put the code inside the Kubernetes API, which means they'd have to wait for every release and get really bloated. So that's wonderful. And it says export CSI snapshots. Why? Because CSI snapshots, in a way, are similar to VMware snapshots. They're not backups. You can do them, you can restore from them, but ideally, for them to be called backups, you need to export them off of your Kubernetes cluster, which Kasten allows you to do, to S3 or to NFS, preferably S3 though. Easy use web UI. So I remember back in 2019 when I first saw Kasten before it had anything to do with Veeam, and I thought, wow, this reminds me of Veeam. It's so easy compared to everything else Kubernetes. So if there's any area of Kubernetes you want to be as simple as possible, it's data protection, right? Right, so we got that. Furthermore, there's integration with Veeam. So there's more and more integration with Veeam, which is nice and cool. Okay. The blueprint concept. So blueprints actually come from Canister, which is a open source solution. It's on GitHub. It's actually owned by Veeam, but it's open source. All it is basically is allowing you to run things inside the containers to prepare the applications for backup. So think VMs in Linux or in Windows where you have pre-scripts and post-scripts. That's simple, right? So you got like, some kind of an application where you need to lock the database. MongoDB even in a VM. Lock command, unlock command. Boom, application aware. That's all it's going to do, but it's going to do it in the blueprint, okay? So that is the application-aware trick in Kasten, and it's quite simple. Obviously, it's much better than crash-consistent backups. You need your applications to be ready for backup. When it comes to application-aware, think of it as like one of those big group photos where you tell everyone to freeze or to shut up, because if they're moving their arms or talking, guess what? You get a blurry photo. Well, think of databases or any applications that have a lot of transactions or things happening in memory. If they're not frozen or not properly prepared, you're going to have a blurry restore, which is no good because you're going to do a lot of repairing then. Okay. Application specific, obviously you can't use a MySQL blueprint to application-aware backup a Postgres or a MongoDB. Goes without saying. And native support in K10 platform. So these were originally, as I said before, created for Canister, but they work in K10. Okay, so the demo will be next. It'll be the next thing I post, probably tomorrow. I'll go over the RAG application. We'll do an overview, and then we'll do a Kasten backup, AA-aware backup of the MongoDB. See you tomorrow on the Kube Vanguard V100 or V100 Underground Report.